All right, students, here is your bell work for the day. Go ahead and pause your screen to complete your bell work. Okay, students, today we are going to be working out the following example, talking about the mass spectrometry of neon, and we have 3 different isotopes, which is what mass spectrometry tells us. We have 3 isotopes, A, B, and C. And what we see is A, this is its relative percent abundance in nature. C, this is its relative abundance in nature. And B, this is relative abundance in nature. Now, typically on this axis, it will give us some better parameters to be able to have an idea of how much is within nature. So we're just going to make up these numbers today that is about to scale. So I would say this is about 75%. So for A, we are saying that it is 75% in nature. So that means C and B have to add up to the additional 25%. So let's say B is about, let's say 20%. And C, we will put the additional 5%. And using this, we are going to find its average, or X with a line over it. That means average mass. And the x-axis is showing us the atomic mass units, which is the way that we are going to talk about mass and chemistry. So with A, which is neon 20, that's telling us that 20 is its AMU. So we're going to take A, since that relates to the 20, and multiply it by the 75%. But with percents, we can't multiply a percent. Percents are basically out of 100. Or you can take the decimal and move it twice. Same with this one. B, we're going to move it twice. And C, we would move it twice, giving us 0.05. So 20 for B is going to be times 22. And this 5% of C is times 21. Okay, I'm going to clear some of this up so that we can do the math. Okay, and so I rewrote those out right here. So we're going to go ahead and do the math. 0.75 times 20, 0.2 times 22, and 0.05 times 21. Go ahead and pause your screen to get those answers. And we get, for A, we should get 15. For B, we should get 4.4. And for C, you guys should have got 1.05. Okay, now this will give us a total, right? So we want to then find the total mass, because when we're finding an average, which like I said, we oftentimes denote as an X with a bar over it. So when we're finding the average of something, you want to take the total, or the sum, which can be signified by the sigma sign, divided by the number of things you're averaging. So we have 1, 2, 3 things we're averaging, and we need to take the sum of these numbers, then divided by 3. So we take 1.05 plus 4.4 plus 15. And that will get you 20.45. So the sum, which is the sigma sign right here, is equal to 20.45. Oops. Wow. And we want to divide that by 3 to get the average. So what we get is 6.81. And that is how you do the relative abundance with your mass spectrometry to calculate the expected mass number. We're going to do another example below. Okay, and here is our second example. We have element Q, and we have the following information about element Q. We have 15%, we have 15 AMU of the isotope 25. We have 16 AMU of the isotope 10, another isotope 17 AMU, and 55% of isotope 18. Right, so these are the isotopes, 15, 16, 17, and 18 are the isotopes, and this is their percent abundance in nature. So if you were asked to draw a mass spectrometry for this element, you would have 25% showing for 15, and then you would show 10% for 16, and 10% for 17, and then you would have 55% for 18. But to calculate the expected atomic mass of the element, what do we need to do? Well, we need to take each of these isotopes and multiply it by the amount of their mass that we would typically find in nature. So for 15 AMU, you take 15 times 0.25 because we cannot multiply a percent. And for 10, we would do, hold on one second, let me fix the pen. Okay, hopefully this will be able to show a little bit better. So here we go. We would do our 15 times 0.25. Times 0.25, and then you would do let's do 16 next. 16 times 0.1, 17 times 0.1, and then you would do 18 times 0.55. And we got 0.55 by moving the decimal twice here, 0.1 by moving the decimal twice here, 0.1 by moving the decimal twice here, and 0.25 by moving the decimal twice here. Okay, I'm going to let you pause the screen so you can finish the math on this. Okay, hopefully you got the same answers as I did. So these would be what go on the sum on the top over, we've got 1, 2, 3, 4 isotopes over 4. And this would give us our average atomic mass found in nature. So we're going to add up all of these numbers right here, 9.9 plus 1.7 plus 1.6 plus 3.75. Go ahead and do that math. And I believe you should have got 16.95, but you always should check your work twice. Yep, 16.95. But then you want to divide it by 4 to find our average. That will tell you what we would see on the periodic table for their mass number, and you should have gotten 4.23. All right, that concludes the practice problems for the day. I'm going to pause the screen and then pull up the exit ticket for you guys to complete your bell work and exit tickets for the day. And here's your exit ticket. I'm going to wait about 10 seconds because you might want to write down the isotopes and the natural abundance so that you can show your work for this problem. I hope you guys have a wonderful weekend and you all are able to finish up some of your homework. If you have any questions, please reach out to me, and I look forward to seeing you all next week.